Welcome to Practice Problems, Unit 1, Lesson 11, Adding Up. Okay, again, find the sum of the sequence. So what we're going to do is hit the math button. We're going to hit the math button and the button next to it, xt, theta, and end. We're going to put in 1/3. We're going to add. We're going to hit math xt, theta again, and we're going to put in 1/9. We're going to hit enter. It's going to give you a decimal. You're going to hit math, enter, enter, and you're going to get 4/9. You're going to get 8/9. You're going to get 13/27. You're going to get 26/27. You're going to get 40/81. You're going to get 80/81. Okay, Priya's walking down the hallway. She walks halfway and stops, walks halfway, stops, walks halfway, stops. After she starts and stops 2 times. So you have 1/2 of the hallway plus half of a half, which is 1/4, giving you 3/4. If she does it 4 times, it's going to be 1/2 plus 1/4 plus 1/8 plus 1/16 is 15/16. And then, will Priya ever reach the end of the hallway? Think about it. In reality, this is a math question that's supposed to be no, but in reality, in theory, this is a math question that's supposed to be no, but in reality, she'll be so close that she can't take any more half distances because her feet are just too big. So this is just one of those math questions. Okay, for this problem, geometric. Multiply, divide. How do we get from 10 to 5? We take 5, we divide it by 10. We get 0.5 or 1/2. Explain how would you calculate the value of the 100th term. What I would do is I would call this 1. I would call this 2. I would write an explicit sequence. H of n equals 10 times 1/2 to the n minus 1. I will stick 100 in my calculator, and I will come up with 10 to the 1/2 over the 100 minus 1. Stick that in the calculator and calculate it, and you'll get a number. Okay, here's the section, graph of sequence R. Define R recursively. Okay, 1, 2, 3, 4, 5. So our numbers are 1, 2, 4, 8, and then 16. Okay, so R of 1 equals 1. And then we're doubling because we did 16 divided by 8 and 8 divided by 4. And then we get R of any term is equal to the previous term times 2 for n greater than or equal to 1. 2, I'm sorry, we started at 1, so this got to be 2. Okay. Okay, an unfolded piece of paper is this thick. Complete the table with the thickness of the paper after it's folded. So now this is backwards. Watch this. If you fold the paper over, it's going to double. So you're adding 0.05. So be careful with this one. So you get 0.1, and then 0.1 doubled up is 0.2, and then 0.2 doubled up is 0.4. Okay, so explicit sequence. T of n is equal to 0.05 times 2 to the n, because we started at 0, so I don't need the whole n minus 1. Okay. Now, what is a reasonable domain? 0 is less than n is less than I don't know, you had to fold the paper. So if you take a piece of paper and fold it like 7 or 8 or 9 times, then the paper gets too small to fold. So take a piece of paper, fold it, and then just come up with your upper number. It's like based on the paper you have in your hand. Okay, we just did this problem before, but now B is different. This 0.5 make a difference. You cannot have half of a fold. You can only fold in whole amounts. Okay, problem 7, arithmetic. As soon as you see the word arithmetic, you're going to write plus, minus, sequence. Starts at 84, and how do you get to 77? You subtract 7. How do I know that? 77 minus 84 equals -7. You subtract going left, or add going left in this case, and you subtract going right. Define A recursively. A of 1 equals 84. A of any term in the sequence is the previous term minus 7 for n greater than or equal to 2. Define it nth term. So that's A, it was in purple. B will be in red. Okay. A of any term is the previous term minus 7 to the n. Because this is arithmetic, the variable is not an exponent. All right, let's put this n minus 1 because we're starting at the first term and not term 0. Now, this is n is greater than 0 because if we put the 0 in there, you'll get the 0th term. You can put the first term. You need the n minus 1. Let's not do this as 0. Let's do this as 1. And that way we'll all be in agreement. There you go. All right. 1 minus 1 is 0. That'll give you the first term. 2 minus 1 is 1. 7 times 1 is 7. 84 minus 7 is 77. That's the second term. And it works. Okay, when you come up with a problem you don't know how to solve, write the sequence out. So we'll call it step 1, step 2, step 3. All right, now, describe how to step 0. So they're calling it 0. This is 1, and this is 2. So you got 3 dots here. 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. You went from 12 dots here to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 12 plus 15 is 27. So this one is a little different. All right, so S of 0 equals 3. Now, S of n recursively gets you the previous term plus 3 times n plus 1 plus 3n. Wow, that's weird. But you take this one, you surrounded it, and then you made another square. You take the second one, you surrounded it, then you make, this is not a square, that's a rectangle. Okay. All right, now to write it recursively. S of n equals 3n plus 1 squared. This is neither arithmetic nor geometric because you times 4 going here, but to get to 12 to 27, you went up by 15. That's when you times 4 or you added 9. So this is just a weird one.